In Brazil's Upper Xingu region, researchers have mapped more than 20 ancient settlements connected by an engineered network of roads, cut through what most people were taught was untouched rainforest. No one has fully explained how a landscape famous for its thin, nutrient-poor soil once supported the kind of dense, organized population that a network like this would require. Some of these roads run for miles in nearly straight lines. Beneath parts of the forest floor sits a black, carbon-rich soil that has no business existing in this ecosystem at all. And researchers only confirmed how it got there in 2024. Over the next few minutes, we will walk through 9 documented findings that quietly dismantled the idea of the Amazon as pristine wilderness. And the strongest one involves a technique so effective that modern soil science still hasn't fully matched it. Here's what we actually know. For most of the 20th century, the dominant scientific view held that the Amazon basin could never have supported large, settled populations. The anthropologist Betty Meggers argued this directly, describing the region as a counterfeit paradise, lush on the surface, but too poor in soil nutrients to sustain anything beyond small, mobile bands. That view shaped textbooks and documentaries for decades, and it shaped policy too, treating the forest as an empty frontier, rather than a landscape with its own documented history. That framing wasn't just outdated, it was convenient. It let outsiders treat the Amazon as unclaimed land, rather than a homeland with a traceable urban past. Whether that convenience was a genuine blind spot or something closer to a useful assumption is still argued over, and it's worth asking yourself which one you find more believable. The researcher most associated with overturning this picture is Michael Heckenberger, an anthropologist at the University of Florida who has worked with the Guaycurú people in the Upper Xingu for more than 3 decades. Beginning in the 1990s, Heckenberger and his Guaycurú collaborators began mapping a site called Cujicugú, a cluster of settlements along the headwaters of the Xingu River in the state of Mato Grosso. What they found was not a single village, but a connected system. Plazas, causeways, defensive ditches, and residential mounds spread across a wide area of forest that showed every sign of having been deliberately planned. That's where the documented trail really starts. Cujicugú turned out to be more than 20 large settlements, some fortified with log palisades, linked by roads straight and wide enough that researchers describe them as engineered infrastructure, not informal paths. Radiocarbon dating places the main occupation between roughly the years 1200 and 1600. The layout followed a consistent plan: circular plazas at the center, residential rings around them, orchards and managed forest gardens on the outskirts. A pattern Heckenberger has called a network of low-density garden cities. Based on ceramic distribution, researchers estimate at least 50,000 people lived across these Upper Xingu towns at their peak, roughly 800 years ago. That number raises an obvious question. Where did they go? The Guaycurú and related Xinguano peoples are still there today, but the large interconnected towns are not. The leading explanation is grimly familiar. European contact brought epidemic disease that moved along trade and river networks faster than colonizers themselves did, collapsing populations before most direct European accounts of the region even exist. By around 400 years ago, most of this settlement network had gone quiet. How much of that collapse happened before anyone wrote it down is a question the record alone cannot fully answer. What the data doesn't explain, on its own, is how any of this was possible in Amazonian soil to begin with. Most of the basin sits on old, heavily leached, acidic ground that loses fertility fast once cleared, which is exactly the fact Betty Meggers built her argument on. So, how did a population in the tens of thousands sustain permanent towns, orchards, and gardens for centuries on soil that should not have supported them? The answer sits in the ground itself, and it's stranger than anything above it. Scattered throughout the basin, in patches from a few acres to several square miles, is a soil local communities have long called Terra preta, or Amazonian dark earth. Unlike the pale, iron-rich soil around it, Terra preta is black, dense with charcoal, and packed with broken pottery and fishbone worked deep into the ground. It holds far more organic carbon than the surrounding forest floor, and that fertility has persisted for centuries after the people who built it left. Some patches run several feet deep, and some deposits date back more than 2,000 years. If topics like this are the kind of thing that keeps you clicking around at midnight, this is usually the point where a channel like this earns a subscribe, because the next detail reframes everything you just heard. For decades, researchers were split on how Terra preta formed. One camp argued it was accidental, a byproduct of everyday village trash accumulating over generations. The other argued it was deliberate, a soil-building technology comparable to modern composting. That should have been a simple question to settle with lab work.
It wasn't. And the debate ran for the better part of a century.
In 2024, a study in the journal Science Advances, led by researchers at the University of Florida and MIT, working alongside Brazilian institutions, added the clearest evidence yet. The team compared modern soil management practices still used by Cuicuro communities, who were interviewed and credited as co-authors, with the chemical signatures of ancient dark earth nearby. The match was close enough to support what many archaeologists had suspected but couldn't prove. At least some Terra preta was intentionally engineered, built through controlled burning and the deliberate working of organic waste into the soil, not simply left behind by accident. Here's the detail that doesn't fit neatly into a tidy resolution. If Terra preta was a deliberate, repeatable technique for turning some of the poorest tropical soil on Earth into some of the most fertile, why didn't it spread as a formal, transmitted body of knowledge the way pottery or weaving techniques did? Officially, the explanation is disease and depopulation. The same collapse that emptied the Xingu towns likely broke the chain of teachers and apprentices needed to pass it forward. The problem is that Terra preta sites are found across a huge, disconnected stretch of the basin, which implies either many groups independently arrived at a similar solution, or a known technique traveled more widely than any surviving record shows. Researchers have not settled which is true, and it remains one of the more genuinely open questions in Amazonian archaeology. This is where most explanations quietly stop. But the scale of what's still hidden is the detail that reframes the entire subject. In 2024, a team led by remote sensing scientist Vinicius Peripato at Brazil's National Institute for Space Research combined LiDAR, laser pulses fired from aircraft that map ground contours through dense canopy, with predictive modeling based on soil type, water access, and terrain. Their study, published in Science, estimated that more than 10,000 additional earthwork sites remain undiscovered beneath the Amazon's canopy, structures the model predicts but that no survey has confirmed on the ground. No one disputes that LiDAR has already found real settlements, causeways, plazas, and platforms confirmed at dozens of sites across the basin, including a dense urban network in Ecuador's Upano Valley, dated to as early as 500 years before the Common Era.
It's the second part that causes the argument.
Whether 10,000 undiscovered sites is a reasonable extrapolation, or an upper bound built on a model untested against the hardest parts of the forest to survey. Either way, the number is large enough that most of what once stood in the Amazon may still be sitting under active canopy today, unmapped, with no fixed timeline for when that changes. So return to where this started. A network of more than 20 settlements in the Xingu, linked by roads that shouldn't have been possible to build or feed in soil this poor. What's proven is substantial. Radiocarbon dates, LiDAR-confirmed roads and plazas, ceramic distributions, and chemical evidence tying modern indigenous soil practices to ancient dark earth all point the same direction. The Amazon supported organized, engineered, populous societies for centuries before European contact, not scattered bands drifting through unmanaged jungle. What's genuinely unresolved is just as real. Researchers still don't know how widely the Terra preta technique spread, or why its transmission broke so completely. And the Peripato team's estimate of thousands of undiscovered sites is a prediction, not a confirmed count. The zoom out here isn't abstract. Somewhere between the confirmed 20 settlements at Cuicuro and the 10,000 predicted but unconfirmed sites elsewhere in the basin sits the actual, still unknown history of one of the largest forests on Earth. And every hectare currently being cleared for agriculture or cut through by new roads is a hectare that might be surveyed by LiDAR next year. or might be gone before anyone gets the chance to look. How many of those 10,000 predicted sites will still be there to find by the time anyone reaches them is not a question the data can answer yet.